Our next presentation is a tag team with Ross and Kevin, who you were hearing about. We're going to stay on the Central Coast. All right, so Ross Clark and Kevin O'Connor from the Central Coast and Ross Stein.
Thank you very much. This is some work that Karen and I talked about a few years ago associated with loss of a lot of riparian habitat within the Central Coast due to some different occurrences with food safety and agriculture. And it was a resource we saw being impacted significantly over a short amount of time. And so we started to talk about, well, how do we integrate an evaluation of the current condition of riparian resources into the Central Coast Monitoring Program. And she challenged me in a few ways, because she also said, and by the way, you can't, whatever you build, you can't actually go out there and do it, because most of the places on the Central Coast, many anyway, we don't have access to. So that was my challenge, and so Kevin and I took that up as exciting and have moved forward. And so this is some of the preliminary data after about a year in the field, and we have another year to go in this work. It is funded by EPA. We are working with SWRCB on some of the mapping, and then we're working with the Central Coast Regional Board. Great. So the goals of the project were to first create a map of our current riparian resource, develop a riparian condition assessment tool for areas with various levels of access, and then work with the regional board to develop an assessment strategy to report on the current condition of Region 3's riparian resources. And so the first step is to map our resource. And that took about 3 hours of a technical advisory committee meeting to realize that that can't be done, because riparian is, it refers to a set of functions that are associated with the area between the stream and the upland. And depending on which of those functions you're most interested in, you would map the resource in a different way. And so we realized that there are a lot of different types of interactions between the upland and the water body that different people and different policies and different laws were interested in protecting or evaluating. So that was our first challenge. So we realized we weren't going to have one map, we were going to have different maps. And so we set out to look into the literature, look at some of the different approaches that are currently underway, use some modeling techniques, and then try and get into a little bit of GIS aerial interpretation using some of our own ideas. So first, we looked at the literature and evaluated, well, what are some of the guidance on how wide is riparian given different functions or support services. And there's a huge range, as you would expect. And for starters, we chose about 200 feet or 70 meters as a ballpark average area that supported most of the functions that associated directly with water quality and in-stream health. We also worked with SFEI on their RIPSET modeling program, which looked at GIS information to basically model the riparian extent given the functions or inputs that it looked at. And then we also used aerial interpretation to evaluate the amount of trees associated to the creek. And that was just for the Morro Bay. And this is what the three maps look like. Here is our standard buffer width, which of course we can change throughout the area if we want to look at different policies or within different stream reaches or orders based on any of our specific on-the-ground information or policy decisions. Here's our RIPSET output, which is modeling the input to the stream from the riparian corridor, as well as the inputs associated with sediment based on various slope characteristics. And then here's our evaluation of tree canopy within those buffer areas. And you can see in the dark green, are the areas where we've identified tree canopy within the buffer or riparian zone around the creek, and then we could then, and then here are all three of them together. We have this is the aerial interpretation. You can see all the pixels. That's all riparian tree habitat. Here is the RipSet model, which took vegetation information and estimated the area of riparian around those creeks using those base layers. And then here is just our standard 200-foot buffer width. You can see they all correlate to some degree, but there are distinct differences based on land use and slope, et cetera. What we were able to do with aerial interpretation of tree canopy then was also to then put it into categories to suggest the amount of tree services or functions that are being attributed to those drainages in those various areas. So we can start to get toward binning our information for future use in our development of assessment tools. So the next challenge we had was to find an assessment method to characterize the condition of riparian habitat. So everyone stop looking in this creek and turn around, look up and out, because we're looking at everything outside of the water for this part. And here are a bunch of the functions that we identified both in literature and policy and from TAC recommendations. These are the types of functions and services that tree canopy and riparian corridor provide to the aquatic resources of the creek. We also identified some that, human benefits that were also important to policymakers and management strategies. We also identified that we went back to Karen's guidance and remembered what this method needed to do. It needed to be rapid. It needed to have a strong focus on riparian, not in the aquatic habitat of the stream or wetland. We needed to have a tool we could reproduce consistent data. And we needed to be able to address as many of the different functions that the TAC identified as possible. All of these, while sometimes not actually having access to the site. We delved into, again, to the literature, found 25 different riparian assessment methods, each for its own use in different areas of California, the United States, and globally. And we selected a set that best represented those functions and best looked like they best met our criteria. Some are from Spain, two of which are from Spain. One is from the arid west, and one is actually developed for rangelands from a group here at UC Davis. We also utilized the tools we'd already built. CRAM assessments focuses primarily on the aquatic habitat, but we were going to use it anyway. And then, of course, we had all of Karen's great monitoring data that she's been compiling throughout the Central Coast, and we wanted to take advantage of that as well. So we selected 20 sites, and we went to each of those, and each of those sites was one of the Region 3's monitoring locations. So we had the data that had been collected there that we could utilize. We ran each of the 6 riparian assessment methods and CRAM at each of those sites, and we did it first by standing on the bridge or roadway, replicating we had no access to the site, but we could visually look at it. And then we did those 6 protocols again in the stream with full access to the site. And then, of course, we established standard assessment area links so that we could standardize the various data. Here's an example of an urban site. Here's an agriculturally dominated site. And here's one of our more natural open space sites. And here is a distribution of the scores for each of the various methods, including the QBR, which was modified by Ohio for their use. So we tried that one as well. Here's CRAM up here, and you can see that there's similarity between in any one of the sites, but there is a fairly large difference in scores. Some of them scored the lowest and the highest, but then they had very little distribution within the median scores. Others had other characteristics associated with them, and we're going to be continuing to look at these data to figure out what this all means. We also compared the scores using each of the individual assessments from the score we gave it on the bridge to what we gave it when we had full access. And you can see a tight correlation with perhaps a little bit more of the sites faring to a higher score once we had full access to the site. But overall, we felt that we could get fairly reproducible scores whether or not we could get full access. We would lose some of the specifics, but overall it was a good representation. So we have 6 methods. We're going to work through and select the best to meet all of our goals, or the best with added metrics from some of the other methods that we liked also, and put those together and go out this summer to do additional assessments. And the idea now is how to meet that second goal, which is how do we compile a set of information on Riparian that could then be integrated with all of the water quality and bug data that the regional board is collecting to help get a better sense of the overall condition of a site, and then how can we use that information and extrapolate it upstream so we can help to address the 80-20 goals that Karen described, around 80% of our watersheds being in good health, 20% moving toward improvements. So that was the next challenge. So we have mapped our resource. We've defined a set of metrics to help assess condition. We also have land use information. And we've also identified the percent of riparian services within a mapped area based on the percent of tree canopy that we were able to evaluate. The next step, of course, is to integrate all this information into a score for that site, and then set up procedures to extrapolate those site-specific scores upstream so that we can get not a site characterization, but a drainage or a watershed characterization. Here's our hypothetical graphical example of our approach. We have an access point here at this road crossing or this stream segment. We can do either a full infield assessment or a road crossing assessment at that site. We're also able to look at the percent of riparian cover within that site as well as upstream of that site. And then we're also able to characterize adjacent land uses based on standard land use maps, which we hope to expand and develop better using some of the more, I think, elegant approaches that Pete Odie and Dave mentioned earlier.
Just a quick clarifying question. Is the blue area the 200-foot buffer or the actual extent of the forest?
It is the 200-foot buffer, or it could be the modeled RIPSET theoretical extent of riparian given the parameters that we put into the model. And we can redefine that in any way we want or based on any policy or function that we're thinking about. So we can look at that, and this was hypothetical. Of course, when we actually did the analysis, there are riparian in some areas that's more a percent cover within that area opposed to a defined band, but the approach still works. So we can then characterize our site as A1. We can get a percent cover of tree canopy. We can get a characterization of our adjacent land use, and then we can actually score the site given our one or multiple assessment methods. We can also then look at water quality and bug data as well to integrate into the area. But then what happens to these other sites where we don't have direct access? Can we utilize this remote information to extrapolate out the information from this site upstream. And that's what we plan on investigating and testing this summer through additional field work, specifically within the Morro Bay watershed. Here's the suggested diagram of what we're intending to do to integrate all of these information in some capacity. I forgot to put the magic happens little square right here, but that's what we're going to figure out this summer. We have our riparian tree canopy cover and the percent cover already defined for our focus watershed. We've analyzed our adjacent land uses and identified ways to extrapolate land uses into stresses. There's a lot more we can do with that, but we have at least an initial set of methods for that. We have selected a set of riparian condition approaches that we can utilize either from road crossings or within the site itself. And then, of course, we have the robust set of water quality and bug data, PHAB, et cetera, that has been collected over the last many years. Somehow, we're going to integrate all of those into, hopefully, a reach level riparian condition assessment that then can be integrated with all of the water quality in water body information to provide us comprehensive an evaluation of these resources as possible. So here's an example of a basic land use analysis, GIS land use analysis, looking at the various types of land use within, this is the Morro Bay watershed. And this is our initial attempt to estimate a potential impact or stress that those various land uses would play on the adjacent riparian resources, with agriculture, urban, providing a negative impact, open woodland, shrub, natural habitats having a possible positive effect. And you can see that much of the upper watershed, which is in forest lands, is adjacent land uses has a positive impact. Down in the urban and agricultural lower valley, we're predicting negative impacts of those on the adjacent resources. We also have our percent tree cover, how much of our expected canopy exists within the buffer that we've identified for it. That buffer we can change depending on how we move forward, but within the 200-foot, 70-meter buffer, you can see our various categories. About 60 to 100% is in dark blue, 0 to approximately 10 is in the light blue, and you can see similar patterns to the land uses from the previous slide. We've now rudimentarily integrated these two sets of information to provide us with an estimate of riparian canopy condition based on those two GIS interpretations for this entire watershed, which is basically rudimentary at this point, and I think what I'm learning today and what we're all talking about is it's in the details on how you take in all these different pieces of information and hone these categories and these colors to best represent real on-the-ground condition or function assessments. So how we're going to take this map and improve it and test it is that this next field season, we're planning to go out into the Morro Bay watershed and go to sites where we have direct access or road crossing access and evaluate the condition of specific reaches throughout the watershed, focusing on areas that within predicted different conditions based on our integrated GIS interpretation. We will then test whether these expected scores correlate or if our predicted riparian condition is significantly different than what we see on the ground, and that will help us to better improve our predicted models using the GIS. The final question, however, is how do we take these scores and this GIS information and evaluate whether or not the Morro Bay watershed has 80% of its riparian resources in good condition and the other 20% increasing in condition, or they do not. So the question is, can we take these site-specific scores and the aerial interpretation methodologies that we have developed and expand that score upstream till we have some indication of a change in the condition based on our GIS interpretation? And then how do we have to go out and do another evaluation at that point, or can we use information from this watershed to estimate what the condition is based solely on the GIS interpretation? Those are some of the questions we're going to be doing this next summer as we go out and use the new tools that we've developed to test our models with real field work. Of course, we'll also be using CRAM methodology and some of our other field indicators, so we have a full suite of information. What we hope after completing this next year's field season is that we are able to generate scores of riparian condition that can be integrated into one of the regional board's report cards as a parameter within a larger aquatic life grade, or also be able to report on condition within an entire watershed using a site-specific full access, road crossing, partial access, and then GIS interpretation. We can build a model to fill in a report card for entire watersheds. And so that's kind of the three-tiered access approach that we're taking and selecting the right tools to populate. The challenge for us, of course, is how do we integrate these using the data that we have to get the best predictive score. And that's it. Thank you. Time for questions?
Yes, we have time for questions. Mr. Ross?
Yes.
I was waiting, make sure I can get anybody else's way. This question could be for you or for others who use binning. And so because you're starting out with continuous data, at some point you decided to bin. And when you bin, you obviously lose resolution and so forth. So what can you think of as a good rationale for binning, and what do you think are some of the problems with binning when you start out with that good quantitative data?
Well, there's a lot of problems with binning, but in many ways, to relay a large amount of information, binning is one of the tools we have to do that, especially when you're integrating a lot of different data together. The biggest problem is that we don't have enough information to really discern what those bin categories should be. And that's why we're taking the approach of having multiple sets of data that we can compare, each of which is evaluating various functions and conditions within the same system. And we hope that that will help drive our binning in a direction toward having that information correlate with other on-the-ground information. But it is a problem, but it's something that to get to a report card level type of information, we have to do it at some point. And the question is when within that integration process is the right point to do that.
Any questions for us?
Thank you very much.